Hey everyone. We just finished Chapter 10, Section 5 on independent and dependent compound events. Today was a good class. We talked about the two different kinds of compound events, independent events and dependent events. They have some very basic definitions. Where independent events, it's when the first event does not influence the likelihood of the next event, while dependent events, the first event does influence the likelihood of the next event. The example we used for independent events were grades. If one student gets an A on a test, it does not influence the likelihood that another student can get an A. One person's A does not take away from another person's A. Whereas dependent events, the first event does influence the likelihood of the next event. And that was an example like if you are getting a prize and if there were 5 prizes for people to be able to get. If one person gets a prize, then that does take away from the ability for another person to get a prize. Independent events. The example we gave were these 3 balls in a bag, and we have 2 green and 1 purple. The question we have is, what's the probability that you will choose a green marble? Well, since there's 2 green marbles out of 3 total, that would be 2 out of 3, or 2/3. So if you take the first ball out and you got the green, what an independent event means is that when we get to the next person, we take that green ball and we put it right back in the bag. So now, what is the probability that I choose a green marble? And the probability is the exact same as it was the first time, because the first event did not influence the likelihood of the next event. So it's still 2 out of 3 or 2/3. Students discussed why this probability doesn't change, and they did a great job. So what's the probability of both events happening back to back? What are the chances I pull 2 green marbles if I replace the first marble after I pick it? Well, we looked at it this way. There are the marbles. I pick the first one, put it back, and then I pick the second one. The probability of the first event, the probability of event A, was 2 out of 3. And the probability of event B was also 2 out of 3 because it did not change. We asked the students, what do you do with these 2 probabilities? And they said you multiply them together. If we multiply them together, 2 times 2 is 4, 3 times 3 is 9, and we get 4/9 is the probability of being able to choose 2 green marbles back to back. We proved this by making a list. You will notice that these are the choices that I had for my first time that I pulled out, 2 greens and a purple. After I pulled out, say, the first green one, the second time I had a choice. I could have either pulled out the green one again, I could have pulled out the second green one, or I could have pulled out the purple. If I had chosen the second green, I could have very easily, once again, pulled the green one, green 2, or purple. And you guessed it, if I pulled purple the first time, that would mean that I'd have a choice of green 1, green 2, and purple the second time. You'll notice that this would make 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities, and that's the 9 of our denominator. The very first choice we had was green 1 and green 1, taking the green 1 twice. The second one was take green 1 first, then green 2, so that's green 1, green 2. And of course I could have chosen green 1 and then done purple. The next group was green 2, green 1, green 2, green 2, and green 2, purple. And the last group was here. Notice there are 9 possibilities, and how many of these are 2 greens? Well, there's 2 there, and there's 2 there. So we found that the chances are 4 out of 9, 4/9, that I pull 2 green marbles. And from here we went on to dependent events, when the first activity does influence the likelihood of the next event. So once again we dropped our marbles back in the bag, and we pulled out the first marble. Once again, there was a 2 out of 3 chance to do it the first time. Now, what we do is we do not replace the marble. And we ask the question, what is the probability to choose the other green marble? And since there are only 2 marbles in there, and only 1 green, that is a probability of 1 out of 2, or 1/2. Why does this probability change? The students, again, did a great job of realizing that when you don't replace the marble, it changes the probability. What's the chances of both of these events happening at the same time, or not at the same time, but one right after the other? Pulling 2 green marbles if I don't put the first marble back? Well, we pulled the first marble at a 2 out of 3 chance, and we pulled the second marble at a 1 out of 2 chance. So the probability of event A stayed 2/3, but the probability of B became 1/2. When we multiplied these together, we got 2 out of 6. We made the list to prove it, and you'll notice that it didn't change my first pull. I still could have pulled green 1, green 2, or purple. But when I pulled the green 1, I didn't put it back, so I only had the choice of green 2 and purple on my second pull. If I pulled green 2, I only had the choice of green 1 and purple, and if I pulled purple, I only had the choice of the 2 greens. So that gave us 6 total possibilities, 1, 2, 3, 4, 5, 6, which was our denominator. And which ones were double greens? That one was double green, and that one was double green. So that's where we got our 2 for our 2 6. There were 2 chances out of 6 that I pulled 2 green marbles, and of course we had to simplify that to 1/3. Well, that was our lesson today. I hope that helps. If you have any questions, please feel free to email me, and you guys have a great night.